Hi, I guess we're going to start. Some people might filter in, but I think it's a good time to start. Before we begin, if you have any questions at all, please save them to the very end. We'll have a question section at the end of this presentation. So with that being said, this is a presentation on smart or smarter facets at Rakuten. Before we get into it, show of hands, before this conference, who here has heard of Rakuten before or used one of our websites or products? Okay, a decent number of hands. That's great. We're trying to grow that. So a little bit more about us. We were founded in 1997 in Japan. Currently, Ichiba Marketplace was sort of our flagship. It is the #1 marketplace in Japan. We're one of the 15 largest internet companies in the world. We have over 10,000 employees, most of them headquartered in our Tokyo office, but we have employees all over the world in many different countries, almost at least several hundred to 1,000 probably in the United States, all over Europe as well. And then we also had over $6 billion in revenue last year from our marketplaces and other units such as financial services and even a baseball team. So very interesting. In the past 5 to 10 years, though, the company has sort of grown tremendously in Japan. There's been a big focus for international expansion. So right now, we have a couple of subsidiaries that are kind of well known in the United States. Viber's an instant messaging app. Overdrive is for books and library. You might have seen them before. Ebates has ads on TV all the time. I'm sure anyone that's watched a Lord of the Rings marathon has probably seen their commercial. Former Linkshare Rakuten Marketing. Kobo, for anyone from Canada, they're the big ebook reader. Slice is a data analytics company based in Silicon Valley, which we purchased last year, I believe. BitNet's a more recent acquisition. They're a Bitcoin company that was based in Belfast that we recently purchased. And then the former Buy.com, Rakuten.com shopping is what we're going to be focusing on today and improvements with that. So a little bit about our technology stack. It's primarily 3 components: Cassandra, Hadoop, and sort of Solar. At the center of it all is where we get all our business value and where things are really driven and derived from. A little bit more about Solar at Rakuten. Right now, we have over 30 different business units that are using Solar, and it's growing every month, it seems like. Currently, we support over 10 different languages in production with Solar, often with custom linguistical features, Portuguese, English, German, Japanese, Chinese. So we have a pretty good linguistical capabilities right now. At Rakuten.com, that is also supported via Solar. It's been that way for several years and been updated several times. We've seen up to around 30 million products on the site, along with 90 million items. We have tens of thousands of unique category ID leaves, and we have millions of unique user queries a day.
So first off, just a quick introduction to Facets. Who here is already familiar with Facets? Okay. So, yeah, a lot of people here, so I'm sorry if I repeat any information here, but I just want to start off with the most basic question. What are facets? Well, they're a set of filter values that are generally returned alongside search results, and they allow the user to drill down into their query to find exactly what they're looking for. They're especially useful for general queries in exploring a data set. Today, though, we're going to focus on how those facets are ordered. To that end, we have created this set of facet sorting criteria, and this is what we're going to use to be evaluating all the different approaches we can use for sorting facets. First, top facets are relevant to query. What does that really mean? Well, just like how you want to make sure all the right items show up on the first page, you want to make sure that your top facets are always in the top 5 or top 10, or what always going to get displayed on the front page. Second, top facet order reflects relevancy. And just like on the first page, you really care about what is the #1 item versus what's the #3 item. That's the same thing with facets. There's a big difference between what's the #1 facet and what's the #2 facet. So you can think about it just like how on your first page of results, you really want to make sure your top 30 are good, but within the top 10 of your search results, that order really matters. That's kind of what these first two encapsulate. Third, easy to maintain over time. We do not want to be spending a lot of time in development time or ops time supporting the solution, so we kind of want to just set it up and let it take care of itself. Fourth, acceptable latency in production. Facets can get really expensive, so we don't want to make this even more intense than it needs to be on the faceting side. In particular with facets, for those of you who've used facets extensively or for even lightly, you probably realize how expensive they can get and how quickly that can happen. In particular at Rakuten.com, we've noticed that faceted queries can be up to 10 times slower than their non-faceted counterparts. So we really have to be careful about how expensive and how intricate we make our facet queries. In fact, if you configure your facets wrong or just have too many facet queries, you can actually end up with OOMs. So it's really important to be aware of how complex your facet queries are and to keep a lid on it before you end up with OOMs in production, and no one wants to deal with that. Now let's take a look at some of the built-in facet sorting techniques we have available to us. For all of these comparisons, we're going to use this same example of iPhone 6 cases. And in this theoretical query that returns cases, we have these facets being returned: OtterBox, Incipio, Apple, and our junk brand AAA phone cases. Here are the search results that generate this theoretical search results that generate these hypothetical facets. We have 2 OtterBox cases on top, then 3 Incipio cases, then an iPhone 6s Plus case bundle, and 4 junk brand cases at the bottom of the search results. So now let's take a look at the 2 oldest and most well-known facet sorting techniques that have been built into Solr, I think, since the beginning. Name sort and count sort. They're pretty self-explanatory, but name sort, you're just sorting based on the actual value of the facet, and count sort, you're sorting on the number of items that fall into each facet bucket. So let's take a look at how these 2 approaches work in our example. Well, in both cases, our junk brand ends up on top. That's far from ideal. And beneath that, we have all other more valid brands fighting it out for the rest of the spots. And obviously, there's a lot that you could do better with this. Really, what's being shown here is that the built-in facet sorting techniques do not really take relevancy into account at all. But there's a new JSON API for facets that adds a lot more functionality, and you can do a lot of cool things, and it's been in there since Solr 5, and it's, I think, a complete rewrite almost of the Facet API. One of the things you can do with it is you can sort on a function. So we could write a function that allows us to sort based on a static score. So if we can add a static score to all of our documents and then sort them that for facets, that may help the situation. Let's try that. So let's add some scores here. Add 30 for OtterBox, 20 for Incipio, 100 for Apple as a top-tier brand, as premium brand, and our junk brand gets the lowest score we can give. If we sort on that, does it look any better? Well, yeah. Apple ends up on top and our junk brand ends up on the bottom, so we've improved the situation. But still, think about what really the user is searching for here. They're looking for cases. They're not looking for phones. So if we were searching for a phone, then Apple on top would be completely valid. But since we're searching for cases, really OtterBox or Incipio should be the first facet result. So there's still a little more work to do here. Just to look back at all of these, the name and count sort really don't take relevancy into account, so they fail on the first two criteria right off the bat. On the third, static score can help with relevancy, but it's not dynamic enough. You can't have it respond to the user query in the context of what the user is actually looking for. So it's still, I give question mark because it can work in some cases, but it won't work in all. However, they are all built in, so they're easy to maintain over time. And things that are built in usually have decent performance characteristics. So they do match on that.
So a static score won't work. We need something that takes context into account. What do we typically look at when we're trying to compare a score and Solar? We look at the actual score that Solar is returning. So let's try this example again. Let's take that same JSON facet, but let's add the field list to the score field, comma score, and let's try to do it on the function of the max of the score. So let's see what we get. Ah, man. Every time. So this is kind of a restriction in the out-of-the-box vanilla. I even did this with 6.2 as well. The fields need to be defined in the index, so it kind of puts you in a tough spot where if you don't have this field, if you don't have a defined field, you have to do something, and you have to come up with a solution. Otherwise, or you could maybe, if you want to get crazy, you could maybe create a lot of static fields and try to do that dynamically, but that would get out of hand really fast. You'd have a very large index. So let's try to take an approach that will take exactly the query score and see if we can come up with a way to do that. So, custom collector. So, who here has written a custom collector for either Solar or Lucene before? Awesome, a few hands. That's great. For those of you that haven't done it, it can work in some cases. Just be really careful. The thing that's great about custom collectors is you can put any logic in there. The thing that's bad about custom collectors is you can put any logic in there. You have to be really, really careful. Just one thing I want to emphasize heavily, this performance aspect. If you're working in a small data set, a couple million, it should be fine. If you're trying to scale in the tens of millions or hundreds of millions and you're not careful, I've seen it go wrong plenty of times. You can basically, though, build a very simple custom collector. Just do a hash map that checks the check the top 100,000 documents, check the scores there, and just sort of build a iterative hash map that will just sort of sort it based on that. That works sometimes. The other problem with that is, anyone here use grouping at all? A lot less hands than I thought it would be. I thought that's a trend, but yeah, I feel you guys pain on grouping. If you've messed with grouping and faceting, it is an unwieldy beast. And if you're designing a collector around grouping and faceting to take relevancy into account, that is not a trivial thing. I know there's still an open Solar ticket specifically on group facet performance, so there's quite a few caveats there if you're using that as well. So this does make a custom collector solution difficult if you're doing that. And then, the other thing that is tough is, depending on your business needs, there could be extra work done during Solar upgrades. I don't know how often your release process is, but upgrading Solar is not always trivial, especially if you have custom non-vanilla logic. So in some cases, it might not make sense to do this. So just be very careful. But I mean, if you have the cycles and you're able to do it, then it can work for you. So what we do instead is we had in our search stack, which I didn't mention, but we actually have an API wrapper around our Solar, which basically gives us a query and result pipeline. And this allows us to manipulate both the query and the results we're sending back to the user. So what we've done instead in our case is we've basically intercept the facets and we can reorder based on predefined business logic and predefined scoring base. So we can pre-compute the scores for most of the user queries and basically return facets based on that. This has a few major advantages. Number one, since we had an API wrapper that was already built, it's pretty easy to maintain. It doesn't cost as much, and also a biggest benefit for us probably is our performance aspect. We can get very good performance. We're talking a few milliseconds typically, and not really hurt end users. And on e-commerce, I think it was Amazon or someone said every 100 milliseconds is extremely critical towards revenue. So we can't sacrifice performance too much. So this sort of speed is really important. And then another one is easy to add business rules. How many of you here have gotten strange requests from business to manipulate your search results? That's about right. So basically, sometimes you could have a sale, like a common e-commerce one, although this could apply to any scenario, is during Black Friday, they could have a special on phone cases, and they could say, hey, I got a promo from brand Z. I want brand Z to be a top facet whenever someone searches for phone cases, no matter what. With this sort of wrapper, it's pretty easy to manipulate and sort of inject it in there. Whereas if you were to do that in solar, unless you were to build some very strange or very intricate dependencies, that could get very hairy trying to do that in a custom collector. So let's look. So the score sort. Right now we have OtterBox at the top, Incipio number 2, Apple at number 3, and the phone case is at the bottom, which, I mean, makes sense. If you look at those search results that we showed earlier, OtterBox was the top one, Incipio was the second, and so on. The question, though, is, should the document scores necessarily reflect the Facet scores in all cases? Can anyone think of a reason why that wouldn't be the case? What? Besides promotions, think of a more like a why would a Facet relevancy not necessarily reflect a score relevancy? Yeah. So what we have is we in this example, let's expand it to include user clicks. In this user example, which we have seen a couple times in production, oftentimes you'll have the OtterBox will have 30 user clicks, the Incipio will have 50 user clicks, Apple will have 10, and the junk brand will have 1. The question is why? Well, I mean, it makes sense logically. If you're looking on a page, you're going to apply a navigator towards what isn't necessarily available right away. So in our example, the OtterBox is at the top and the Incipio is below it. So if you're a user, you're going to more likely click on what you can't see rather than what you're already seeing. Because if you have good search results, you shouldn't even need to apply a filter, some people say. So this is where it gets a little interesting. So what we need to do is we need to come up with a way that takes into account both the score and the actual user click data. So what we've done in our model is we've sort of blended them together. And you can use some level of machine learning to sort of pre-compute a score and then plug it in there. So let's go back to that wrapper we had. So as you can see here in our little model, the user goes to search, they get the data back, we get the scores back, and we also get the user click and user information back. We sort of blend it all into here and create a feedback loop and feedback in the solar. So let's take a look at how this would look if we blended it. In this case, Incipio would be number 1, OtterBox would be number 2, and Apple and AAA phone cases are near the bottom where they belong. Now, I will say, not all queries have this much user data. Not all cases are like this. But the thing is, those cases where you do have the user data are often critical because those are often your most important queries. Those are the popular queries. And those are the queries that drive your revenue. Oftentimes, if you look at your sales, you'll see a small percentage of your queries make a huge amount of your money. So getting it right for the really popular queries is really, really, really critical. So that's why we think this has a big advantage. So the impact was coverage of significant user queries. If you've noticed my careful wording, I've said user queries. I will be the first to admit this solution isn't perfect. We don't cover every possible query, which is fine. I'm sure most of you who have live sites have dealt with bots before, and a decent percentage of our queries are bots, so we've sort of built our logic to filter out the obvious bot queries like number, and just iterating through and the UPC type numbers. So we've sort of filtered those out and built it specifically around the high-end user-based queries based on our logic. Another advantage, which I mentioned before with grouping, since this is done in an API wrapper layer, it's very easy to plug this into grouping, and we don't have to deal with any of the group.facet or grouping logic, so we can let Solar handle the grouping portion and our wrapper handle how the facets are redisplayed, which is a nice perk for our different services. We actually are expanding this to our other services that use grouping more extensively, so this is a very big benefit to us. And then probably the biggest one, as I was mentioning before, the search latency aspect. We've seen almost no impact on search latency. Our 99th percentile SLA time is typically less than 5 milliseconds added on from this. We've extrapolated that from our stats, and we've been able to see that typically this portion takes less than 5 milliseconds at most. So it's been very good, and it's, it hasn't had those issues we've seen with sometimes messing with custom collectors too much. So let's go to a brief summary here. Let's look at let's break it down. So top facets relevant to query. In each case, these are all matching. These are all great. The top facet order reflects relevancy. You know, the score and the score API wrapper are kind of similar here. I will say it's not always, in a lot of cases, this probably will be fine, but for very popular queries, you know, the blended is going to beat it, but, you know, again, it depends. So this one's kind of a push, but typically this is going to win. The third point, easy maintain over time. The custom collector at this time for us is probably, it can be a push. I mean, honestly, it depends on your business and relevancy rules. I've seen people do this as simple as a simple hash map. I've seen people with multiple hash maps and other things like that. So this one really depends on how complex your logic is, especially if you're blending in other signals and user data. I mean, the custom collector really just depends. And I mean, but the score wrapper and the blended result, since those are both client side, those are pretty easy to maintain. And then, yeah, the acceptable latency and performance, similar to this one, where it really just depends on your custom logic and if you built in certain optimizations, your collectors. But at least our client-side wrappers, they're very, very simple and straightforward, so we haven't had to worry about, you know, latency issues with that and had to sort of benchmark around that. So let's look at some real-world examples on the live site. One of our hotter items right now, the Samsung Galaxy. Yeah, I was a little mean, I know, sorry. Samsung is at the top. Another one that's interesting is a diamond ring here. So you'll notice, like, you'll see yellow gold on top. You'll see platinum right here, and then gold plated down here. So I guess more people like platinum than gold plated. Who figured? And then, of course, coffee. We all love coffee. So nothing really says good morning to the office like a fresh cup of Keurig coffee, I guess. So getting that Keurig coffee in the morning is really good. And as you can see here, we're showing it to you first.
So just to close out here, evaluating all of the facet sorting solutions we looked at today, the built-in ones really don't take relevancy into account at all, and so they can't make a dynamic enough facet ordering for any given user query. If you start mixing in the score, then it improves the situation a lot. But still, there are times when the facet relevancy can diverge from the search relevancy, or should I say the just general search result relevancy. So being able to use a blended approach where you can give the facet relevancy a nudge in a different direction, or really just give it different rules so you can adjust it, allows you to give a optimal user experience for the facet ordering, and that will give you the best experience you can give for facet ordering on your site.
One last one before we get to questions. If anyone has a solution in mind or think they have a better idea, that's great. I have a suggestion. Come work with us. We are hiring. Both me and Mike, actually, we actually work in Boston. So anyone not familiar with Boston, this is a South Station. It's downtown. Our office is literally right there, I think. And yeah, it's a really fun office, and it's a great environment. We also have offices for people not based in the U.S. or who do not want to work in Boston. We have our main headquarters in Tokyo, which is part of our team as well. And we also have a team in Paris as well. So we have search teams in 3 great cities. So if you're looking for a job and want to live in Boston, Paris, or Tokyo, let us know, because we're looking for talented search people that could, you know, maybe improve the solution or work on some of the other million search problems that we're dealing with. So, questions? Yeah. Yeah, I think it's funny you mentioned that. The counselor, I think the counselor's actually pissed off more people. Some of our, so our team's kind of interesting. We actually work with a little background. We're part of RAC USA. We actually work with the different subsidiaries in the Rakuten group in the US. And typically what I've noticed is if you just sort on count, they get more pissed off because they say, like, on almost every e-commerce scenario at least, there's a lot of spammy listings. So you need to have something that is more relevancy based, and they definitely, almost all of them really hate count. That's the one thing I've noticed, especially on really generic queries. iPhone in particular is a really bad one because It turns out every product now has iPhone in its description. So you'll get thousands of items from like even like rugs or something like that say like this is an iPhone designed rug or some nonsense like that. So it has been a serious problem. That's sort of why we did that. We said relevancy, and we just said we've improved. I mean, we're not doing pure clients; they're within companies. So I mean, we sort of had a little bit more leeway. We typically say we're working on improving relevancy, and in some cases, if they want to do custom logic, we do listen to them on that. That's the bigger feedback. Whereas if they say they really, really, really need something, we'll adjust on that. It's sort of been like a more that way. And we've tried to also build some A/B tests and some reporting around it. But yeah, they've given a little feedback, but since they're within company, it's not quite the same as like, as a contractor model or a consultant model where you need to explain every little detail. We have a little more flexibility, I guess, in that sense. But we have typically said it's relevancy-based combined with user data. That's typically what we just say to them. Yeah, I'll try to say as much as that won't get me in trouble. So yeah, we are able to sort of capture the scores, and we have a good idea of, say, the top 100 to top 1,000 results per query. And we sort of built that into a model, and we can sort of process that pretty quickly. And we sort of feed that into our loop pretty quickly on the fly. So it's just sort of a thing we do offline. We basically pre-computed almost all the scores for all the queries, and we sort of do that. So there's like sort of it's not technically real time. So yeah, in cases where a new query becomes item, like if we, like when Pokemon Go went live and those Pokemon Go products came live, there would be a bit of a lag time before our model reflected that, and that's probably the biggest disadvantage too. So but it's basically like, done with it. Once we get enough user data and once we know the scores, we can sort of pre-compute it, because we're doing a lot of offline score processing because we can basically simulate what the solar scores are going to be. Yeah, we can do streaming as well, but typically we do batch because you want to have a certain amount of user data because you can get a lot of spam too. Specifically, the bots are pretty nasty if we're not careful with them, because you want to typically look, especially in IPs. We've noticed that certain IP addresses we need to double check because there'll be certain patterns across IPs. So there's certain things we need to check for. What? Yeah, we do all the facets actually. We do brand, color. The only one we don't do currently in the Rakuten.com is category, just because at the moment, that's just because there's business rules for showing the taxonomy tree. We want to change that in the future, but all the other facets we do have control over, and we do with our logic. Yeah, that's dynamically generated by the front end, so it depends on. I know on certain sites, or not certain sites, on certain parts of our site, it depends on the category and store you're in. So if you're in a certain store, if a cell phone filter's been applied, we're automatically generating facets for different iPhone attributes, and then those different facets are being called automatically as part of our logic. And then we're sorting those facets as well, like carrier and things like that. Is that sort of what you're referring to? Yeah, yeah. That's at the moment, yes. That's actually that's being migrated as well over. So in some of our, it's like half and half. So we actually support some applications where we do that, some applications where the client site does that, and we're trying to basically take it all over. But yeah, it's like a half and half approach. It depends on every BU's needs, I guess. And I saw some hands over here in the back. So we handle a group. So when you're talking about the issue where we don't know the number of groups available, so I think you could do that by sharding. So we shard based on the group ID, and that does give us typically an accurate number of groups. But I mean, realistically, we know it's going to be slightly off. But if we're talking, 30, I know like 50 million, 100 million, a couple off isn't really a big deal. At least in our case, I can't speak for. I know legal compliance stuff might be a bit different, but I mean, we typically handle it. And our client wrapper, I mean, the facet response is still in the same format. All that's handled within the grouping is that you might add logic, like you might only return the top one. Either there's two ones. So there's one where you can collapse it, so you only return the top documents facet count towards the group, which is fine in some cases. Or you can try to use group.facet if it's performing, which will then take each unique attribute from the group. But typically to get that working, I believe you need a custom collector because there's some issues I know at scale and Solar with that. So, all right, anyone from over here? I don't think. Oh, it depends. Honestly, it's you have to just do A/B testing and see what happens. It depends on every query. Anytime you're dealing with user data too, there's a certain noise threshold. So, depends on the query. It depends on how much is there, and then it kind of just depends on how critical it is. I haven't. I think it's just we have to look at the total number of queries, the total number of user data available. I think once you get above a certain amount, then we can sort of turn it on. But again, it sort of depends. I mean, I don't know off the top of my head right now, but I know we sort of try to do a balance on it because we're still sort of experimenting with the perfect value. That's the next step. That's a very good question. That's sort of the next roadmap, at least, is to sort of do that. The plan would be not only to do that, but also to sort of give an associative score, so that if you're a front end, you would basically know, hey, I know for this query we should display these facets and display these attributes, and then they can collapse or they can rearrange the UI based on that. Especially on, I didn't really want to cover that because it's more still in development, but basically like you would on a mobile app or an iPad, for example, you would know, hey, this is really critical. We know this facet is really important. Let's put it at the top on the mobile space where it's really precious, where space is really precious. So that's sort of the phase 2 and 3 approach that we're working on. Good question. Not off the top of my head. I don't have that on me. I do know it has been approved. It's been more businesses complained a lot less about to us. But I don't know in terms of CVR numbers, I don't have that off the top of my head. I'm sorry. I'm talking about clicks on the facet attributes. Yeah, I don't. That's not. That was just an example. I think typically what we like to do for this type of situation is we like to do both the clicks on the attributes and then also the clicks on the attributes that lead to a purchase. So there is a differentiating factor, and I didn't cover that as much as I should have. But yeah, we typically try to do that, especially because that typically filters out a lot of the bot traffic that we see. Uh, Not really. I think trying to think. We've had more. Generally, the funny thing is, a lot of people don't pay attention to facets. It's kind of interesting. They only pay attention to facets if it's like really terrible. Typically they focus more on the relevancy, but it's kind of an interesting thing. I'm trying to think about now. Yeah, I don't really think people complain about. They were complaining before we implemented this, and those complaints have gone down. But they haven't really complained about just why is this order changing? Because we always. I mean, the thing is, the index is changing daily and changing constantly anyway, so it's going to change. So I think they sort of accept that. But yeah, I don't really think it's kind of interesting. When you're talking about like they refresh it and they see it changes like constantly, or
we're not refreshing fast enough for that to be an issue where you're really like going from one refresh instance to another. It's more like a daily change. So you're not. I don't think you're going to see a scenario where you were running one query and then you're like on the second or third page and you decide to run a facet, and when you go to the third page, the facet order is changed. Uh, I mean, it could there could be a slight change, but generally major changes. I mean, where with the machine learning model being put in place, there's there's waiting in place so that there isn't major changes being made over time. It's more of a push.
Also, just one other thing. I mean, we're doing changes on the front end all the time too. Anyway, I mean, we're always constantly running A/B tests, which slightly adjust it anyway. So in one sense, it would be no different than any other like A/B situation where users like one day you'll see one situation and the next day you'll see something that's very very different. That's just part of the normal flow of a website. So I don't think it's too bad. But yeah, that's an interesting one. Any others? Yeah, it's exactly re-rank. Yes. Only the top in this case. If we were doing a collector, we could do a re-rank. Depends on the logic. So, there's a fair question of is a re-rank even needed, like completely for all of them? We typically only focus on the top ones. We'll try to know which ones are top and re-rank those, but it does get tricky because you can't say re-rank the top, count ones. Because the example I go back to is, say you search for just iPhone. On one of our clients, the brand that was showing up for iPhone with the lowest count was Apple, because every other brand had a million like iPhone accessories. So when you look, if you expanded the brand facet on one of our clients, Apple was way down the list. So we do have to sort of like just try to find the really top one and make sure that goes up. But we won't like say like there's 5 or 10 near the bottom. We won't typically touch those. We try to focus typically on the ranks that people are going to see. We don't really care I don't really care if the 50th facet is suddenly the 75th facet. Most users are pretty impatient, and if a user really is going past the top 10, I think we're doing something wrong with our search, and we should figure out why they're doing that rather than, worry about like the ordering for the bottom ones. Yeah, so test automation. We have on our test sites and our live sites, we typically do. So we have in our facet in our plugins, we typically do unit tests, and then before we do production deployments, we do have a process where we have typically the services have a decent amount of automation, and we also have our own automation as well that we are running before every deployment, and there's a full process for that. But yeah, it's always a worry with changes like these that we will accidentally break something that no one knew about, but we typically try to make sure we're very upfront about these changes, and we try to make sure our automation doesn't break our search process, and then the services doesn't. But I mean, on our end at least, we're basically an API. Our search stack is an API that the services are using, so it typically shouldn't break it. It should on our end, we just need to make sure that we're not breaking our search core and our search results by having some, like for example, say they index garbled data and we get some weird facets. We need to make sure we handle those cases. But typically, we try to cover ourselves, at least in our aspect of it. Any other questions? We try to measure it by what we do to see the impact of CVR. So typically what we try to focus in on is sessions that lead to purchases. We try to figure what sort of a percentage of the time we're having an impact on that, and that's typically been our metric. So we try to basically see of the queries that lead to a purchase that implied facets, what chances are we doing that we had like the number 1, 2, or 3 result on that, and that's sort of like been our metric to see like how we're doing on that and where we can look to improve. And as a follow-up, I don't have numbers, and I guess we have to stop now. So thank you all for your time. If you want to see us, come to our booth or talk to us directly.